Up till now, we have seen that in part modeling, we have basically three types of features: primary features, secondary features, and treatment features. Out of that, extrude, revolve, and sweep are primary features because they can be created as the first solid of the part. Hole and rib are secondary features. Secondary features are those which can add or remove material on the primary features. Then shell, draft, and pattern are treatment features. Treatment features are those which can which can be created on edge or surfaces of the object. So friends, what are we going to study today? Concept of the blend tool, blend types, parallel, rotational, and general, some rules which are to be followed in blend tool, tutorial come exercise for parallel blend, operating blend vertex utility, what are start points in blend tool, creating a rotational blend, and finally an exercise on general blend. So friends, let's try to understand the concept of blend tool. A blended feature consists of a series of at least two planar sections. That is, blend can have only sections and no trajectories can be used as in sweep command. Any number of sections can be blended, but minimum two are required. So again, a blended feature consists of a series of at least two planar sections that are joined together at their edges with transitional surfaces to form a continuous feature. Again, remember that blend can have any number of sections but no trajectories. In cryoparametric, we have three different ways of blending sections: parallel, rotational, and general. In parallel blends, sections to be joined are placed on planes which are parallel to one another. In rotational blend, sections are placed on planes which are rotated along a single common axis. Maximum angle permitted is 120 degrees. Maximum angle between any two sections is 120 degrees. In general blend, sections are placed on planes which have a translation distance as well as rotational angle. It's a combination of a parallel and rotational blend both. For the tutorials and exercises for the blend tool, let us go through some important points which are to be kept in mind before operating the blend tool, irrespective of the type of blend, whether it may be a parallel blend, a general blend, or a rotational blend. First is as we have already discussed, only sections can be used, no trajectories can be used, as against sweep command which generates a solid by using a single section and a single trajectory. Blend command can use no trajectories but only sections. Second and the most important point in blend tool is that all the sections should use equal number of entities. Say for example, you want to blend a rectangle and a circle. Since a rectangle has 4 number of entities and circle is a single continuous curve, you cannot use you cannot blend both these sections directly. Circle has to be divided physically into 4 parts so that the number of entities per section for rectangle and circle are equal, and then you can generate a solid. The last is the exception to this rule is, however, you can blend a point with any section irrespective of the number of entities. So with this prior knowledge, let us start using let us see some tutorials and exercises of the blend. Let's learn how to operate the parallel blend tool in cryoparametric with the help of a tutorial. The solid shown in the drawing is generated by blending 4 sections: a rectangle of 290 by 190, a circle of 145 units diameter, a square of 145 by 145, and a circle of 40 units diameter respectively. Let's see how to operate the tool and create the solid in cryoparametric. In the shapes group, select the blend tool. In the sections tab, select the define button. Select the sketching plane on which the first section for the blend tool is to be drawn. The first section is a rectangle of 290 units by 190 units. Each section in the blend tool will have a start point as indicated in the bottom left corner. Start point is the point from where the mapping of all the sections for the blend tool will start. Press the OK button. Again in the sections tab, OK button. Again in the sections tab, input the offset distance. Input the offset distance of section 2 from section 1, which is 175 units in our case. Press the sketch tool. Then draw the second section. The second section, as we have seen in our drawing, is a circle of 145 units diameter. As we have already seen that in order for the blend tool to be successful, all the sections should have equal number of vertices and entities. Since the rectangle has 4 entities and 4 vertices, the circle has to be divided into 4 parts. For that, 2 construction center lines are to be drawn, and the center line are to be coincident with the vertices of the rectangle. Make the center lines to be coincident with the vertices of the prior drawn rectangle. Then next part is take the divide command and divide the circle into 4 number of entities. As we have already seen that all the sections should have equal number of vertices and entities. So now your circle is divided into 4 parts. Okay, so each vertex of the rectangle is mapped with each vertex of the circle, and you get a blend as shown on the screen. Then again in the sections tab, insert the third section. Input the offset distance of the section from the second section, which is 100 units as shown in the drawing. Then again the third section is a square of 145 units by 145 units. Since square has 4 number of sections and entities, 4 number of vertices and entities, you need not to divide the square. Then again the screen shows a solid which is generated by blending a rectangle, a circle and a square. Then again go into the sections tab, insert the fourth section, input the distance of the fourth section from the third section. Again go into the sketch tool and sketch the fourth section. The fourth section is a circle of 40 units diameter. Again, since circle is a single closed curve, you have to divide the circle into 4 equal parts with the help of 2 center line as shown in the prior example. This time the center line is to be coincident with the vertex of the square, since the circle is to be blended with the square. Okay, so make the center lines coincident with the square vertices of the square and divide the circle with the help of divide command into 4 equal parts. If you notice the start points of all the sections are having a start point, and the start points of all the sections are aligned on the same side of the vertex in all the sections. This is important to get a smooth solid. So the final figure shows a solid blended by a rectangle, a circle, a square and again a circle. The preview shows a smoothly blended solid. Then in the options tab you have 2 options, straight and smooth. Straight indicates that the sections are to be joined with a straight line. You can see the difference on the screen. The second option is smooth, in which all the sections are blended to form a smooth solid. Okay.